The screen is visible, right? Okay. So regarding the quiz paper, are you able to see my screen? Is it visible? Okay. So I'll just give you an idea about the quiz. So the whole content will be from week 1 to 4. Okay. And around 15 questions will be there. And mostly MCQ type of questions will be there. And some NAT also. Around 10 to 12 MCQ and around 3 to 5 NAT will be there. Mock will be released tomorrow, so that also you should be solving. Okay. So I'll go through the week wise and tell you all those things that you must be knowing. Okay, that you can't leave. Let's for example from week 1. See, uh, so for at least the basic signals you must be knowing. Okay, basic signal means the unit step or delta function. Okay, unit ramp, rect function. So this 3 4 function or signum also. 3 4, at this basic you must be knowing. Okay, how does you represent the step function, delta, ramp, rect function or signum function. Okay, at least this basics you must be knowing. Okay, and the other part, the operation on any signal. So the any signal can be given in the form of, let's say example xt, and then you have to do some operation like scaling, shifting. Okay. This all things you must be knowing. So these are the very important portions. And half of the questions, the whole paper, half of the paper will be consisting of this type of questions only, like paragraph type of questions, where you will be given the xt and then you will be asked what is the, like, which of the signal represents the scaling by 2 unit. Or one more thing you must be knowing, many a times what will happen. Okay, many a times you will be given the signal something like that, x2t, okay, or x3t or x half t. Okay, and then you will be asked to represent the signal. But many a times what will happen, you will be given the xt, but it will be given something like delaying by 3 units or advancing by 4 units. Okay, or expanding or compressing by 2, scaling by 2, some like expansion or compression. In that way also it will be given. Okay, so you must be knowing what is advancing, what is delaying. Okay, you should not be getting confused. So if it is given in this way, then it's pretty simple. You will be able to know, right? In this, you just divide the axis by 2, here you multiply axis by 2, all the values of axis, right? But it is given like expansion, expanding your signal by zero point 0.5. Okay, so that also you must be knowing. Okay, or compressing by 2 units, so that also you should be knowing what I'm doing. Okay, so you can be written in the verb form, like expanding or shifting or delaying, and then you'll be asked what is the analytical signal. So xt will be given, and then after, okay, I'll go through that question, but I'm just giving you an idea. So in the first 5 minutes I'm just giving you an idea about the paper. Okay, so this type of questions you must be knowing. Phasors you can like exclude for this, like phasors not that important for your paper also. So phasor, if you are not comfortable, you can just skip as of now. Okay, so what did I say, all these things you must be knowing, and then all the application on the signals. Okay, this basic signal you must be knowing, and also very much the delta is very important, so you must be knowing all the properties of the delta. Okay, that I'll discuss today also, but I'll just give you an idea. So delta is very important. Delta you can't leave. Okay, so some questions will be directly from the properties of the delta functions itself. Okay, and the next part will be the classification of the signals. In the classification of the signal also, you must be knowing even and odd, periodic function. So here you must be knowing how to calculate the fundamental period of any signals that has been given to you, whether the signal is periodic or not. Okay, and here also whether the given signal is even odd, or for a given signal find out the even part and the ordered part. Okay, so this type of questions will be there, and from the periodic you will be asked to calculate the fundamental periods or whether the signal is periodic or not. The next part will be the energy signal and the power. So you'll be given the energy or the power signal. It may be a periodic signal, then you'll be asked to calculate the power, or maybe a given signal will be asked to calculate this energy. Okay, for some of the standard signal like the exponential decaying, you must be knowing what is the energy, or maybe for the rect function or the for the triangular function, you will be given. You can calculate with the formula like integrating that also, but for some 3 4 standard signal, you must be knowing the direct energy and the power. Okay, so that you can directly calculate it there. Okay, so these are the important portions that you must be knowing. You can't skip those portions. Okay, is that clear? Can we move to the solving part, the question solving part? These are the most important portion. Some standard signal, and then all the whatever you do like scaling, shifting, all those things, and the mix of all those, and the classification of signal. These three are the most important. Okay, others like the orthogonal, you may just be knowing the formula for those cases and what is the basic idea about the orthogonal or the anti symmetric, conjugate symmetric or anti conjugate symmetric, that you already know from the that similar behavior is similar as the even and odd function. Okay, is it clear to everyone? Are you guys there?
Sir, can I, sorry to interrupt.
Yeah, yeah, yeah.
Actually, I joined little later. Can I know this is like a quiz and revision or
The quiz one revision.
so can you means what is the topics for quiz and so from week one to
Week 1 to 4.
oh, okay, sir, okay, sir. And this
So
quiz will be released on what?
what will
Mock,
release?
mock, sir, mock.
Mock will be released today.
Okay, sir, okay, sir.
Yeah, and I already told you the all the important topics also that you can't skip. That is the most important. Okay.
In this live session only, right?
Yeah, yeah. In the starting 10 minutes,
Yeah, yeah. So I means I'll watch this later. This video will be uploaded.
yeah, yeah. It's already there. That's like a live video.
Okay, sir. Thank you, sir.
Okay. Yeah. Okay. So see how the questions will be. You will be given a signal xt. Okay. So this is the first question that we are solving. Signal xt will be given like this. So this is xt minus 1, 0. This is 1. This is 1, 2, 3, t, and has been given here 2. Okay. So in the paragraph of questions, you will be given the signal xt, and then the questions will be the you have to plot. The first question will be to plot x of 1 minus t. How will you plot this? And fourth thing that I told you, right? The fourth thing that you will be given, like it will be given something like, okay. So this is the first question, and I'm telling you what are the four things that I told you, right? that can work as a revision also. So let's, for example, any signal xt has been given to you. So delaying a signal, you already know that that means t minus t naught. So this signal is delayed with t naught unit. Okay, or you call it as right hand shift. So in the question, it will be like a given signal xt has been delayed with t naught unit. So you must be knowing what you have to do. Okay, or if it is given like advancing, that also you must be knowing x of t plus t naught. So left hand shift, or it has been given something like xt has been given, and then it is said that it is compressed with by 2 unit, compressed by 2. So that means what, x of 2t, or it has been given it is expansion by 0.5, then this is x of 0.5. Okay, so it can be given in this for mathematical version also, or it is just be written as like the given signal is delayed with t naught unit, or advanced by t naught unit, or compressed, or expansion. Okay, so that also can be given, but here you have been just been given the xt is given, and then you have to plot x of 1 minus t. So can you just tell me the steps that you follow to plot in
Yes,
for any
yes,
given
yes.
signal? What are the steps that you follow?
Yes, so first we write the x of 1 minus t as x of minus t plus 1. Then shift the signal left hand side by 1 unit, and then we make the signal. Uh,
Reversal.
Time reversal.
yeah. Time reversal.
Correct, correct. So the every step you'll be following for any question for given xt. If you have been asked to plot anything like plot x of, let's for example minus 2t plus 3, or if it has been written something like minus x of 3 minus 2t. So the first step, your first step should be to write in the form of y equals to mx plus c, or whatever you want to call it as mt plus c. Okay, in this form you should be writing. So here also you should just write it in that form. So that will be minus 2t plus 3. And then second step should be you start from look, like mostly we are solving in the backward propagation. Okay, we are not learning forward at all, because you will be getting confused in the exam. So start from the left hand right hand side itself. So the first thing that we'll be doing, so the first step should be you just write it in this form mt plus c, and then you should start from the right hand side. Okay, like our backward propagation that you call it as. Okay, so the first thing should be shifting, and then you'll be doing the scaling. Okay, with minus 2. So first thing is what, shifting. If you are doing for this question where you have been given minus of x of minus 2t plus 3, you'll be shifting. And how you'll be shifting, left or right? Left hand side, right, by 3 unit. Okay, and then the second step should be what, the first step is what, you're just replacing t plus 3. This is the first one. The second one, what you're doing now, you have to replace what, t with 2t, or you can directly write it as minus 2t. So there what you will be doing, you will be doing the all the axis values will be divided with minus 2. Correct. And then the third step will be you are multiplying the amplitude also with minus 1. Are you getting? So this is pretty simple. So here I just gave you this example because this includes everything. You are doing shifting also, scaling also, and amplitude multiplication also. So if the signal was like this, you would have, what you would have done first, you would have started, first you would have written in this form mx plus c, and then from right hand side you would have started, or backward propagation you have done. First you would have done the shifting by 3 unit left hand side, because here you can see that plus 3 is there, and then you would be doing the scaling part. Okay, whenever you do the scaling, whenever the value of a is greater than 1, like if you just uh, include this minus sign for a second, if it is 2t, then what you will be doing, whatever the axis value that is there, that is just divided with 2. Okay, and if it is minus 1, or you can divide with minus 1 or multiply with minus 1, both are same. Okay, so for our case, where it has been given to plot x of 1 minus t, first step should be you just write it in the form of y equals to mx plus c, then it will be minus t plus 1. Now the second step would be first shifting it left hand side. Okay, so shifting left hand side is what? Axis of minus 1. Okay, and then time reversal. So you can, after that, you just divide whatever the axis value that you are getting, divide with minus 1 or multiply with minus 1. No problem in that. So that will be the value. Okay, so when you will be doing the axis of minus 1, this will go to minus 2, this will go to minus 1, this will go to 0, this will go to 1, and this will go to 2. Correct? So the range of this whole function will be what? From minus 2 to 2. Correct? And after that, what you will be doing? You will be multiplying with minus 1. So that is not going to impact. So whatever the value that was there, whatever the value that was there at minus 2, that will go to 2. Okay? And the vice versa. Is it clear to everyone, or should I plot this? Is it clear
Just
or
plot
not?
it, sir, for reference.
Okay.
So plot
Okay,
it.
let's plot it. Okay. Okay. So we have to plot x of 1 minus t. So I told you write it minus t plus 1. What we have done? Axis of minus 1. That was the first step because the shifting, and then you have divided with minus 1. Okay. So now my whole values will be something like that. I told you axis of minus 1, then this will be minus 1, minus 1, minus 1, minus 1, and minus 1. So it was minus 2, minus 1, 0, this will be 1, and this will be 2. And now I am dividing with minus. So the first step should be, the first step, I'll just write it as x of t plus 1. So this, how will I plot? So the whole thing, only the shifting part will be there. So it will go, it will be minus 2, then will be minus 1, it will be 0, 1, and 2. Okay, so this function is x of t plus 1. And now we just have to do the time reversal. So whatever the value that is there, just you can divide it with minus 2 or minus 1. And whatever the value, that will be a time reversal. Okay, or what you can do is time reversal, like you can just take it like the rotation, or you can say that image in y-axis. That also will work. So whatever the value that was there, because what we are doing axis, whatever the value into minus 1 or divided with minus 1, both are same because we are doing the time reversal. So whatever the value that is there at minus 2, that will go to 2. Okay, so this will be what, if you'll just try to plot it off, it will be something. So this will go here.
Basically, mirror image.
Yeah, correct, mirror image. Okay, and this value will be coming here minus 2, minus 1, 0, 1, 2. Okay. Is it clear? So this is what. So what you have done? First you have done the shifting. So in the shifting, like left hand side shifting, you have done axis, whatever the value of axis was there, -1, because you are doing shifting all the values to left hand side. Now in the next step, what you are doing? You are doing the reversal. In reversal, what you are doing? Basically, axis multiplication with -1 or division with -1. So in that, what is happening? Basically, whatever the value was there at -2, it was going to 2. So you are just basically taking the image in y-axis. Okay, so whatever was there in the positive side will go to the negative side, and whatever there in the negative side will go to the positive side. Mirror image in y-axis. Is it clear to everyone?
Yes, sir.
Okay. So I hope this type of problem is coming in the exam, and that will come. So for sure in the exam. Okay. So you'll be given any values, and you will be asked to calculate 2 minus t or 3 minus t or anything. So you'll be doing same thing, minus t plus 2, first shifting and then time reversal. After shifting, whatever the image that you can see, that take the mirror image in the y-axis. Clear with everyone?
Yes, sir.
Okay. So now in the same given function, okay, in the same given function, if you have been asked to calculate x of t times del of t minus del of any value, let's for example, this is del of t minus 1 minus del of t plus 1, the same function. This is the same question. The question number 2 is, the same signal has been given to you xt, and now it has been asked to calculate xt times del of t minus 1 minus del of t plus 1. What you would have done? The properties, basic properties, you know, of the delta. If you don't know, I'll just write it, some of the basic properties. Okay, the first properties of the delta function, and this is important, very important. The delta function is the most important. If any other standard signal, if you are not aware of much, that will be fine, but delta you must be knowing, because explicitly it has been the whole 4 week is on delta only. So delta, you can expect some 3-4 questions from the delta. So for this type of questions, there are some properties for delta. So the first property is, you must be knowing how the delta mathematically you write. Okay, so this is written something like that, right? So delta function is what? Is infinite at t equals to 0, and at t equals to not 0, it is 0. So this is how you write mathematically. But you already know that if you are integrating it from minus infinite to infinite, or 0 plus, basically 0 minus to 0 plus also, where the delta is defined. Okay, and if you are doing delta t dt, it is basically 1. Is the first uh, properties of the delta function. You already know that the width is tends to 0. Okay, and the magnitude at t equals to 0 is infinite. Okay, but the delta function many times you must be given in 1, like the value will be given as 1. So that is not the magnitude, that basically is the area of a delta function. Okay, so the area of a delta function is 1. Now the second property is what? If any function that you are multiplying xt with delta t, basically that becomes what? Any function that has been given. So let's, for example, xt is given something like that, and then you are multiplying a delta function, and delta is just defined at t equals to 0. Correct? Right? So this function will be what? X of 0 times delta t, or any value. Let's, for example, it is given xt times delta of t minus t naught. Okay, so this will be what? At t equals to t naught only the delta is defined. Okay, so that's why you just be writing x of t naught, because at t minus t you are just multiplying xt with the delta function, right? And then delta is just defined as t naught. So at t naught only, the value is 1, and here whatever the value at, let's for example at t naught, whatever the value of x is given, right, x of t naught will get multiplied with 1 and you'll be having that value. So del function, del of t minus t naught, because delta is just defined at that particular point, right? So x of t naught multiply with del of t minus t naught, correct? Because delta function is just defined at t naught, so you'll be having this value. So this is the third property. Okay, so the other most important properties for the delta function is delta of at, we just write it as 1 upon a times del of t. Okay, or if you want to write it as like this, a times t minus t naught, then the delta function is 1 upon a del of t minus t naught. So this you can think of as 5 properties, and the most important property is what? When you integrate it. So the same thing, when you integrate it, let's for example the step has been xt del of t. So after multiplication you are integrating also del t. So now what will happen? So this you already know, right? The function is just defined at t equals to 0. The delta function is just defined at t equals to 0, right? So this value will be what? X of 0 times del of t. And now you are integrating from minus infinite to infinite dt. So this is a constant. This will come out x of 0, and then you are integrating from minus infinite to infinite del of t dt. So this is what? This is 1. So your value will be what? This value will be x of 0, because the delta is just defined at x equals to 0. Now, so this is the 6th properties. The seventh property you can think of as x of t del is just defined at t minus t naught, and now you are integrating minus infinite to infinite dt. Now the delta function is just defined at t equals to t naught, right? So this value will be what? X of t naught times del of t minus t naught, correct? And now you are integrating from minus infinite to infinite. This is a constant that you can take out, right? X of t naught and then minus infinite to infinite del of t minus t naught dt. So this is what? This is 1. So now your value will be, this value is what? X of t. So this 7 property you must be knowing. Any doubt in this?
No, sir.
No, right? Okay. So now if you don't have a doubt, let's solve this problem. So your problem was this question, xt was given, and then you have been asked to calculate xt del t minus 1 minus del t minus 1. What will be the value? How will you represent that? So the function, what you will be doing? What did I say? Some properties, xt times del of any function. Let's for example del of t minus t naught. So that will be, what will be the value? X of t naught times del of t minus t naught, right? So the function x t naught, right? The function will be just defined at t naught, correct? Because delta is not defined in other places, are there? So this value will be what? X of 1 times t minus 1 minus x of minus 1 del of t plus 1, correct? Are you there?
Yes, sir.
Are you able to understand this or not?
Yes,
Right?
sir.
So the function at x equals to 1, what is the value?
2.
The value is 1, right? So you'll just represent like this. At x equals to minus 1, the function is not defined. So there won't be any value, right? Because 0 times any value will be 0. And at x equals to 1, the value is 1. So you'll be representing like this. At 1, the value, you will just represent at 1.0, because when you represent, you just represent the area of a delta function. Okay? Is it clear or? Sorry. Is it clear? If it's not clear, I can just reiterate it. No problem in that. But if given in the exam, you must be able to solve it.
Sir, in this minus x of minus 1, why? How does it come minus 1, sir?
Okay. Because the delta is what defined at minus t minus 1, right?
Oh, okay, yeah, inside parameter. Okay, yes.
Yeah. So if it just defined at minus 1, you'll be just taking because x ka
Yes,
function can be anything.
yes,
But if you are just
exactly.
multiplying with some del of t minus t naught, only t naught value will be coming out, right?
I got
Sir,
it.
here
I
x
got it.
Just
of
give me a second.
1 is 2 over 1.
What?
X of 1 is 2 or 1. How can we can identify it as 1 or 2?
Okay, sorry. See, at t minus 1 minus, the value was 1, but at 1 plus, okay, at exactly at 1, the value is been not given. See, so what you can do is, there's a phenomena, right? Gibbs phenomena. Generally, how do you take the value? Yeah, so this was just a random question that I have given. But if using Gibbs phenomena, the value will be 1 plus 2 by 2. So it will be 1.5, but
Okay, so in the exam, if we will get that kind of question, we have to take the value 1.5.
just give me 1 second. I'm having a sneezes. Just give me 1 minute. Yeah. Okay. Yeah. So what was equals to 1, right? So because x equals to 1, because 1 minus is 1 and 1 plus is 2. So using the Gibbs phenomena, you can just write it as 1 plus 2 by 2. So basically 1.5. Okay, so you can represent as 1.5. But mostly in the exam, it will be given something right here, so where the value will be there, where the value you can directly calculate, or here. So if it was delta of 1.5, you would have known, right? I don't think so. They'll be giving at 1, right? Because at 1, you don't know it is, because 1 minus is 1 and 1 plus is 2. So if it has been asked at 1, you'll be writing 1.5, because I told you, right? In the unit step also, because in the unit step also, when I was teaching the unit step, you already know that at 0 minus the value is 0, and at 0 plus the value is 1. So at exactly at 0, you use the Gibbs phenomena. So basically that is 0.5. Okay. So this is how you can write it. If it has been asked at 1, you'll just take the average of 2.
Okay, sir.
Okay. But mostly it will be
So
asked where
for
there is a
unit
continuity. There is no discontinuity. Mostly it will be asked at the continuous place, not at the discontinuous. Yeah, yeah. Go ahead.
okay, these are discontinuous point. Okay, limit is different. Yeah. Okay.
Okay.
Now for unit step function, if someone asks for
At
u
x
of
equals to
0,
0,
then
yeah, it is
it
0.5.
is
Like you use the, yeah, the value is 0.5.
okay. Okay.
Any doubt as of now? Anybody? So this two type of question that I solve, you must be able to solve. So delta function, that whatever I have solved, that you must be able to solve in the exam also. I'm just giving you some more questions from delta function. I have a cold. Sorry for that. So the question number 3. So let's, for
Sir,
example, your question is one. Yeah.
there is any MATLAB code questions in quiz or
No, no, nothing. No, no. Yeah. How will you solve this? I told you all the properties, right? All the properties, and any delta function, you don't have any value that I'm giving. In the exam also, you'll be asked to integrate this equation. So you don't have to integrate it. Like you use the, everywhere the delta will be given. If delta is given, you just have to use the properties of the delta.
So here x of t is t squared e to the power of minus t squared by 2, and t minus t naught, that
So
delta,
this you can think as function ft.
yes, that's a function.
Okay, the delta is defined at which place?
Yeah, and delta is minus 2 plus 1.
So 1 minus 2t equals to 0, right?
Yes, that's yeah, t is equal to half actually. So we have to define the function around t is equal to half actually.
Yeah. So the function is just defined at t equals to half.
So
So
that
okay, after
so,
calculating,
yeah.
yeah, or you can just think of as. So what will be the value exactly? You just put the value of t equals to half or what?
There is no time scaling also. So first we have to define that function in terms of del of x plus t, or just that is possible.
What? What? So at t equals to half, the function delta is defined, right?
Yeah,
Okay,
that's the amplitude. That's the max actually amplitude of the delta
Okay.
of this function actually. This
And you already know that. Yeah, you already know that also. Whatever the function. So f of t. So f of half and del of whatever the value 1 minus 2t dt. So this will come out, and this integration from minus infinite to infinite del of 1 minus 2t dt will be 1. Correct? So the function's value will be what? 1 upon 2 pi times this value. Correct? So if you'll just put the value of half here in ft, what you'll be getting? 1 by 2 whole square times e to the power minus 1 by 2 whole square by 2. So is this correct or am I doing anything wrong?
correct.
No, sir, I think we
No.
have in delta function, we have a scaling factor is also
Correct.
given. So we have to
Yeah.
divide by minus 2.
Correct. Yeah. Right. I told you something right here. When delta function is something like that, right? So if the scaling factor is there, you have to divide something. But
or
here
yeah,
also,
define the amplitude.
yeah, right?
Yes, sir.
Yeah. So here you have to divide with 1 upon 2 also. So while solving, this should be there in your mind. So del of, if you are writing this minus t plus 1.
Could that be minus 2 or
No, see, delta function, how do you represent delta function? Delta is a even function. You write it delta t or you write it delta minus t. Both are same, right?
yes, that's
This
a
is
property. Yeah,
1.0.
right. That's a property of that.
Correct. So if you divide it with, so here basically you write it as mod. Here you write it as mod of a. So whether it's a or minus a, it will be mod of a. So both will be same. Okay. So here you just divide with 1 upon 2 also. So now your value will be 1 upon 2 ka whole square into 1 upon 2 and times 1 upon 2 pi and e to the power whatever the value that is there, to the power minus half square by 2. Is it clear to everyone? I hope now you'll not be doing any mistake, right, in the exam also. So, okay, yeah. So similar question, if I'm giving you question number whatever 4, 5, if you have to integrate it minus infinite to infinite e to the power minus t del of 2t minus 2 dt. Here it's pretty simple. E to the power minus t del 2 you'll be taking common t minus 1, correct? Right? So at t equals to 1, so this function f of 1 and 1 half you will be dividing, correct? This will be the answer. Any doubt, anyone? No, right?
No, sir.
So delta is done. So all this type of questions will be there. I am just giving, so you can just try it out. That also, I'm just giving one question. This you can try it at home. Question number 6. So you have been given. So, and one more thing, rect function you should be knowing. Okay, if you have been given only the rect function, that also you should be knowing. Rect function, I told you, this is a standard function, standard signal that you must be knowing. If you have been given a rect of t upon tau, this you must be knowing. This value is a. So basically you represent as a from where to where? Minus tau to tau. Sorry, minus tau over 2 to tau by 2. So whatever the value that is there, that is the width of the rect function. Okay. See, here I am just giving you in the form of a value. So here, let's for example, the question is xt is been defined as value 1, t equals to minus or mod. I am just writing in the form of mod to 2 or 0, or at other places the value is 0. Okay, and then you have been asked to calculate, integrate it from 0 to 5 2 times t minus 3 del of t minus 4. The similar question, right? Or in this way it has been, can be represented, or it can be represented as rect function, rect of t upon 2. So xt is given like rect of t upon 2. So you must be knowing how the function is. If you are not able to plot this function rect itself, how will you solve this one? You will not be able to, right? And one more thing, so this you just solve at home. The other problem that I'm giving you, if you have been given del of t plus 1, and then you have to integrate it from 0 to infinite dt, what is the value?
1.
Anyone else?
Oh,
0.
0 to
Yeah, it will be
0 to
0.
infinite. It is 0.
Yeah, because when I told you what I said, when you are defining del function, del is infinite at t equals to 0, and then if you calculate the area from 0 minus to 0 plus, so while integrating that at the point at which the delta function is defined, that must be coming in the integration. So here the delta function is defined at minus 1, but minus 1 is not coming, right? From 0 to infinite we are like integrating. For this function itself, let's for example the delta function is defined at minus 1, but you are integrating from 0 to infinite. So the area will be 0 only here, correct? If you are integrating from minus 1 minus to minus 1 plus itself, then the integration, then the area will be 1.
So the
Okay.
limits play a role over here to define that
Yeah.
value of the delta.
Correct. If any area, let's for example, if you are calculating the area of this rectangle from 1 to 2, 1, if you have been given integrated from minus infinite till 0, the area will be what? If this is xt, so if you have been asked to calculate the integration of this will be 0 only, right? If you have been asked to integrate it from 1 to 2, then only you will be calculating the area 1 times 1, right? If you have been asked to calculate from minus infinite to 0, the area will be 0. Same case for the delta also. Delta is just defined at del equals to t equals to 1, t equals to 0. If this limit is coming at the point at which the delta is defined, if that point is coming, you integrate it, you will be getting the integration as 1. But if that point is not coming, then the integration will be 0. Making sense?
Yes, sir.
Yes, sir.
Okay. So now I hope, yeah, got it? Okay. So I hope this, at least from the basic signal part, you must be aware like which type of questions will be coming from the delta and the any operation that you are doing on the signal. Okay, now we'll come to the classification of signal. In the classification, I told you these three you must be knowing: even, odd, periodic, and the energy and power signal. Okay, other function like the orthogonal signal, basic. Okay, well, just the formula if you are knowing, that is more than enough, and the symmetric and anti-symmetric also. But this three that I am defining, like discussing, that is most important. The first one is even and odd signal. You already know x of t. If x of minus t is equals to x of t, this is even, and then x of minus t is equals to minus of xt, then this is odd. Okay, but mostly this type of question won't be coming whether the signal is even or odd. The signal will be given to you, any signal, and then you have to find out the odd part and the even part for any signal. That will be asked to you. Okay, so how do you calculate the even or the odd part? The even part for any signal that you calculate, for any signal you'll be having the even part and odd part. You can calculate it, x of t plus x of minus t upon 2, and the odd part that you calculate, x of t minus x of minus t by 2. Okay, there are some other questions also that I didn't discuss, but after, maybe if we'll get the time after discussing this three type of a signal, we'll go through some other questions also. But yeah, as of now, the even and odd signal is clear to you, right? So mostly it will be asked to calculate the even and odd part of a signal, not much. So let's deal with one example. So what will be given is, let's for example, a question that I'm giving you. You have been given the xt. So the xt has been given to you. Okay. Okay. And you have been given the odd part also. Just give me a 1 minute. Yeah, I'm sorry for that. So xt has been given to you, and in the odd part, it has been given that some part of the odd part has been given. So this is not the total odd part. This is the some part of the odd part. So you have a signal. This will be having the even part, and this will be having the odd part also. Some part, like partial of odd part, has been given to you. I don't know from set. Okay. Okay. Now you have to give me the total. This is the partial odd part. You have to give me the whole odd part. How will you calculate that? See, even though this was not given, you would have calculated the odd part. Now, if this information has been given, now half of the portion has been given to you. You just have to calculate half of the other half. Okay. So what are the steps? Odd part, you calculate as x of t minus of x of minus t by 2. Correct?
Yeah, so if half
For
of
this
odd
signal,
part,
x,
then we can take the symmetry about the origin and we can calculate whole odd part.
correct, yeah, correct. So that is why I have given the half portion. If you have been given the partial portion of the odd part, you don't have to go and calculate with this method, because even though you can calculate with this method, But why to go? Because partial has been given. You already know that the odd signal is symmetrical about origin. Correct? So you just have to take the other part. Why should? Is it clear to everyone? And if you have been given the even part, the partial even part, now what will you do? The whole odd part, how will you calculate? The odd, the even function is symmetrical about what?
Y axis.
Yeah, this is symmetrical about y axis, and the odd signal is symmetrical about origin. Is it clear to everyone?
Yes, sir.
Okay. So now, even though you can use the other method also, if I would not have given this, you have to solve with this method only. Okay, and in the exam, any of the two can be coming. Either they can be giving you the partial part, and then you have to calculate the full part, or for that you must be knowing the properties, right? Or you will be given the whole part. You will be given the xt, and then you have to calculate the odd and the even part. And this is very highly like this will be asked for sure. Okay, so this whatever the question that I am discussing, it will be asked in the exam for sure. With different signal will be given to you. Not the exact question, but the different signal will be given to you. So these are the very like this type of question will be there in the exam. So you can practice more. The other type of question from the periodic. So odd and even, this type of questions will be there. These are the some properties. Like for the odd, symmetrical about origin. For the even, symmetrical about y-axis. Now the periodic signal. From the periodic signal, you will be asked regarding the fundamental period of a signal. There will be mix of 2-3 signals, and then you will be asked to calculate the fundamental period, or you will be asked to calculate whether the signal is periodic or not. I'm just giving you some questions that will help you to know whether how to check whether the given signal is periodic or not. See, if let's for example you have been given the signal question sine of okay, whether the signal is periodic or not.
Periodic.
Not periodic, right? Why?
Yeah. Because the ratio of both the fundamental period of individual signal is not rational.
Correct. Yeah. So for this, what is the time period for this signal? If only this was given, what is the time period? Just give me 1 minute. Yeah. Sorry for that. How do you calculate 2 pi by omega, right? What is the omega here? 100, correct? So the time period is 2 pi by 100. For this case, what is the omega? 300 pi. So the time period is Then 1/50. This is T2. You already know that for any given signal, this T1 upon T2, like if you have more, then you can take the ratio for those cases. But this
One
must be
150, no? 1/50.
Yeah, this is 1/50. So this must be rational. Then only it must be periodic. So for this case, for our case, T1 upon T2 is coming in the form of some pi value that is not rational. Okay, so that's why it's not a periodic signal. So mostly it will be asked regarding whether which of the following signal is periodic or not periodic. Okay, so you can check with this method. Now, or you will be asked to calculate the periodic, like the fundamental period. So if you are able to calculate this, then I guess we can move to the next topic, sine. What is the period fundamental period? What is omega? Omega 1. What is omega
100.
2 and what is omega 3? Omega 1 is 100. This is 300. This is 500. The fundamental time period is what? So the
Pi
see,
by 50, pi by 150, and pi by 250.
so see, there is two methods. If you know the omega 1, omega 2, omega 3, how can you calculate? You calculate the highest common factor of 300 and 500. That will be what? 100. And from here, you can calculate the time period. Time period will be 2 pi upon 100. Or the other method can be you calculate the time period T1, T2, T3, and then calculate the LCM of T1, T2, T3. You'll be getting the pi upon 50, same one. So either you calculate with this method or you calculate with this method. Okay, but only thing that should be there is if you are calculating with the help of omega, right? You calculate the highest common factor, but here least common multiple. Is it clear? Making sense?
Yes,
So
sir.
here 100, 300, 500. The highest common factor is 300, right? So you got the 100, and then from here you can calculate the time period. Okay. If this is clear, then the next question that can come from the periodicity is you will be given, let's for example, you have been given that xt and yt both are periodic signal with fundamental period 3 seconds. Fundamental period. Now you will be asked to calculate the periodicity of zt. That is what? X of minus t plus y of 2t plus 1. Some properties I am telling you, if you know the time period of any signal xt, okay, and if you have been asked to calculate the time period of at, then the time period is what? 1 upon a times the time period of xt. This you all must be knowing. Okay, these are the only properties. For shifting and all, the time period is same. If you are shifting or reversing the signal, the time period is always same. Only if you are doing the scaling, then it is getting divided with 1 upon mod a. Okay, nothing else. So now you have to tell me for this signal, what is the time period for this signal?
1 by 1.5.
What is the time period for this signal? What is the T1? T1 is 3 seconds. T2 1.5 seconds. Now you have to take the LCM of T. LCM. If you take the LCM of 1.5 and 3, it will be 3, not 1.5. Okay? You are getting right? So this is 3 seconds. So do not get, like, after knowing the concept also, just while taking the LCM and HCF you are doing them. So you should follow only one method, right? LCM or LCF. Okay, so here you see, if you know the time period T1, so if you have been given the form of sinusoidal, then this omega and all comes, right? If you are just given this, you just have T1 and T2. You have to take the LCM of both. So LCM, if you are taking, you'll be having least common multiple, right? So you'll be having 3 as the answer, correct? It's clear? Is it clear to everyone?
Yes, sir.
Okay. So now the next part you must be knowing is the inner. What is that? Yeah. So energy and the power signal, right? Okay. Just energy and the power signal. That is the remaining portion. The energy and power signal. How do you calculate the energy of any signal? And how do you know whether the given signal is okay? One more thing, in the periodicity, if you have been given something like that, so this. So the time period is what?
1.
Or the fundamental frequency, if I have been asked, how will you calculate? The fundamental frequency is what? 1 upon T. So that also you can calculate, right? Time period, if you know, fundamental frequency you can calculate, right? Or if you've been given something like that, so you have to take care. See, if the signal is something like that, right? And again, it is starting here. So the time period that you will be taking, right? This should not be only this one. You have to take from where it is getting repeated. So here, from here till here, and then again it is repeating from here, right? Correct. So the time period will be, so you, these all things are very basic, but in the exam, if it has been given many a times, what people do, they'll just take the time period as this. No, the time period is from where the signal again started repeating. Okay, so this should be the time period. Clear, right? Yeah. So each and everything I'm telling you what the mistake that you can do. So if you have been given in the form of a if the signal has been represented like graphically, then not do the mistake just by taking the time period. So you just take care like from where the signal is getting repeated again. So that will be like that measurement we must be writing as a fundamental time. Now, energy signal. The first thing is, how do you know whether the given signal is energy signal or not? I told you two things, right, during the session. What are the two things that you should be taking care to know whether the signal is energy or not?
Finite magnitude.
The first thing is, if the signal is, if the signal is of finite duration plus finite magnitude, or if the signal is of infinite duration at t equals to minus infinite or plus infinite, the magnitude should start tending towards 0. If any of the two is happening, then you can say that this is an energy signal. Okay. Okay, so this is what? This is finite duration, finite magnitude. That means this is a closed signal. And if this is a closed signal, it will be having some finite area. And then if it's a finite area, means finite energy. That means a signal, energy signal. And for an energy signal, what is the value of power?
0.
0, right? And for the power signal, then energy infinite. Okay, these all are basic, very basic thing that you must be knowing. Okay, yeah. So this is the energy signal. The formula also you must be knowing how to calculate the energy signal. The energy signal. What is the formula for energy signal?
Mode of xt square dt integral from minus infinity to
Correct.
infinity.
Minus infinite till infinite x of whatever the function that has been given as square dt. Okay, this is how you calculate the energy, right? So now you have to calculate the energy. I'm giving you a signal. So and see, this type of question also can come. You have been given a xt. First calculate the odd. What is the energy for a odd part of the signal? So first you have to calculate the odd part, and then calculate the energy, or even part and the energy. So okay, so you can't skip, like you can't leave that. So what did I say? For the even and odd, for any signal, you must be knowing how to calculate the even and odd part. That you must be knowing. So that if you have been given to calculate the energy for those signal, you must be knowing how to calculate the at least the even and odd part. If you are not able to, then you'll be able to miss both the questions, the even odd part also. And if you don't know the signal, even and odd part, you'll not be able to calculate the energy also. Okay, so you can practice those type of questions. Now, let's say example, this is signal. Whether first tell me whether it's an energy signal or not.
Yes, sir, it is energy, finite duration, finite magnitude.
Yeah, correct. What will be the energy for this signal? How will you calculate? This simple, right? How do you calculate? Integrated
First,
xt ka whole square. So you can see that from 2 to 4, the value is 3. That means 3 ka whole square times 4 minus 2 plus 5 ka whole square times 7 minus 4. Correct? This is energy. Is it clear to everyone or not?
yes, sir.
Okay. And some of the properties of the energy signal also I'm giving you. See, whenever you do the shifting, there is no change in the energy of a signal. Only the when you are doing the scaling. Okay, so let's say example, energy of x of t plus minus t naught is same as the energy of x of t. Okay. Yeah. Only the energy will change when you are doing the scaling. At. Then the energy will be what? 1 upon mod a x of t. Or you are doing the amplitude. If you are multiplying some amplitude, so if you have been asked to calculate the energy of k times xt, then it will be what? K square times energy of xt. Because you already know that if you are like multiplying some amplitude, what will happen? You already know that the formula, right? Xt, you are doing the whole square. That means what? If the k was there, k square will come out. Is it clear to everyone?
Yes, sir.
Now, if let's for example a question was given that the xt has an energy x, Now, what is the energy of x of at minus b? What will be the energy?
Ex by mod.
Correct. The next question is calculate the energy for a signal given as ut minus u of 10 minus t. Calculate this. I'm giving you 2 minutes. Calculate. This is pretty simple. You calculate it. Is it done?
The question screen.
Have you tried this? This question. How will you represent, first of all, how will you represent this? In the normal session, I told you, right? If you have been given a signal u of t plus 3 minus u of t minus 3, how will you represent this signal?
It equal minus t in the value and
How?
yeah.
See, from minus infinite till t equals to minus 3, the value is 0. At t equals to minus 3, it gained a value of 1. So it will start having a value of 1. It will go till t equals to 3. At t equals to 3, the value again is declined by 1. So it will again come out here. So again it will go like this. Okay. This is how you define the signal. And if you have been asked to calculate the energy for this signal, what will be the value?
Six.
Correct. 1 is whole square, 3 of minus 3 will be 6. Now calculate this. The value will be infinite. Okay. Any of you can just tell me how the value is infinite? Can somebody plot this one? U of minus t plus 10. How do you plot? See, you are not ut.
Sir, will it be like between -10 and 0, the value is 0 and other is
No. See, see then how the value will be infinite? The energy value will be infinite. The value of energy is infinite for this case. See, ut has been given. Now you have to plot what? U of minus t plus 10, right? And then you have to do the subtraction, correct? So you plot it, u of minus t plus 1. So first you do u of t plus 1 and then the time reversal, correct? So t plus 10, so it will start from somewhere minus 10, correct? And you do the time reversal. So if you will do the time reversal, you will be having left with what? Correct? This is minus t plus 10. Now what you have to do? You have to subtract this. See, from minus infinite to till minus 10, the value is 0. So 0 minus 1 will be what? 0 minus 1 will be what? Minus 1. Correct? See, you can see that, right? This value ut and u of minus t plus 10. This you can see, there is no intersection, right? Are you able to see that? So if you
Yes, sir.
do this ut minus u of minus t plus 10, you will be having some value from minus infinite till minus 10 also it will be defined, and from 0 to infinite also it will be defined. Okay, if you will calculate the energy, what will be the value? See, u of t minus, so if you just plot minus also, it will go white, it will multiply with minus 1, so it will go something like that. Are you able to understand this? And then if you just see minus infinite to 0 minus 10, the value is 0 here, and here you have some value 0 of minus 1, you will be having some 1 value, right? So it will be defined at from where to where? So it will be defined somewhat like this. So if you calculate the energy, it will be infinite, right? Have you understood or not? Should I repeat it? Have you understood or not? Should I repeat this or you have got it?
Yeah, got it.
Understood.
Got it, right? Okay. Now the next part is the power signal. Okay. So first of all, I'm sorry. Yeah. And one more thing, in the energy signal that I was calculating, you must be knowing the energy for some of the very standard signal. Like for us, power minus 80 UT. Do you know the energy for this signal? Exponential decaying.
By 2, I think.
1 by 2a. And if this is for this case, what is the value? 1 above 1a. Right? What is the energy for a rect function? So these three you must be knowing. Okay. In the exam, if you can ask directly, you can calculate it, right? Okay. So next part is the power signal. What is the formula for the power signal? So power signal, you can calculate it for the periodic and aperiodic, right? Two type of a signal can be power signal, right? A periodic signal, mostly it will be asked regarding the periodic signal. How do you calculate the power for a periodic signal?
It is energy, average energy means we take that
Correct.
one.
Energy for a one duration and upon the time period. Yeah, this is the correct way. Or you calculate it with the formula minus what is the t by 2 to t by 2, whatever the time period has been given, x square dt. Okay, so this formula will work everywhere. Any signal, let's for example, signal has been given. This is 1, this is 2, and again it is getting repeated 1, 2, and the value is 1, 2, 3. Okay, so for this case, how will you calculate 1 ka whole square times 1 minus 0 plus 2 ka whole square 2 minus 1, and what is the time period for this graphical signal?
3.
3. Correct. So this is how you calculate the power. The only one thing that you must be having in your mind is whenever you do the scaling or shifting, there is no change in the power, right? Because you are doing dividing with the time period also. If you are scaling, if there is a change, like if you are scaling, there is compression or expansion, right? So the time period will also change, right? So both will get cancelled out. So power, even though you are doing a shifting or a scaling, there won't be any change in the power. Okay, only with the amplitude if you are multiplying. So power for a signal x of t, shifting though there is no change, the power of a xt itself. Or if you are doing power of x of at, then also there is no change. Only there is a change when you are multiplying some, if you are doing the scaling, k times xt, then k square times. Okay, is it fine? So mostly from the power or the energy signal also very basic questions will be there to calculate the energy and the power. I hope whatever I have discussed today is clear to you guys. And mostly if you just go through this and try to solve each and every like one or two questions from whatever I told you, that is like that will suffice. Okay, so you try to solve each and every question whatever the topic that I have discussed today. That will be more than sufficient for your paper also.
Okay, so when
Okay,
mock is there any mock or
mock will be released today. It will be released today.
okay?
Okay, so you can just solve the last problem of a day. So let's for example, this is
So just a reconfirmation, it will be a subject, it will be objective, right?
yeah, it will be objective.
Okay, sir.
I told you 15 questions are there. Some 10 to 12 are MCQ and some 3 to 5 are NAT. Okay.
Okay, sir.
Yeah. Calculate the energy of this signal -1 to 2, and this is 2 e to the power minus t by 2. What will be the energy? I told you for a rect function a square tau, for energy for a exponential decaying function 1/2a. So this 2 3 that I have told you standard signal, you must be you just remember that, or you can calculate it there, but it's better you remember. What will be the value? See, 2 is square, 1 minus 0 plus. So for this, what will be the energy signal for this exponential decaying? 2 times, what do you say, 1 upon 2a. What is the value of a here?
Half.
2 square or it is
Yeah, 2 is square. So we'll be having 2 is square here also. So 4 plus 4 equals to 8. Okay. Any doubt that we have discussed today in any of the questions? And the question that we have discussed, more or less, you'll be getting the similar type of questions in the exam also. So I try to cover each and every topic. Those are important for you. Okay. You can go and practice at least the topic that I have discussed. Is it clear to everyone? Any doubt that you face?
Yes, sir. Yes, sir.
sir,
Any of the questions?
this year's academic paper civil system quizzes or like that for practice.
What? I can't hear you. There is a lot of break.
Previous
Can you just repeat it?
previous academic quizzes question.
Previous?
Previous year means
Okay.
previous.
Okay, yeah. So what I'll be doing, will be releasing some of the previous term papers itself as a mock. Okay, that will be sufficient, right?
Okay.
Okay. And do not rely only on the previous term paper that I am reiterating again and again. You will not be getting the same questions. Okay, as I can see, some of the previous term papers that was almost similar, but you'll not be getting the similar questions. Like the questions will be from these topics only. Whatever I have discussed, if you'll just focus on those topics, you'll be in a very much better position. Okay.
Okay, sir.
Okay. Then okay. So we'll meet again, I guess, in the coming sessions, and all the best for the quiz paper. Okay.
Thank you, sir.
Thanks,
When is the next session, sir?
The next session will be happening on Wednesday.
Okay, sir. So that will be a revision or that will be a new one, new topic?
No, that will be also a revision. We'll be solving some problem. Yeah.
Okay, sir.
Does it, can we discuss the week 5 doubts on the session?
Week 5 we are not discussing because we will be discussing just after the quiz paper.
Okay.
Okay, sir.
Oh. Okay. Thanks everyone for joining.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.